So I welcome all for the next lecture series on projection of straight lines under the course Engineering Graphics. So in the previous lecture, we saw about projection of planes, construction of 2D lamina with the help of the simple basic projection method, say orthographic projection. Likewise, how to project the one-dimensional element, a straight line, using horizontal plane and vertical plane. Consider an object, a straight line, positioned relative to any one of the reference plane. We have to draw the projection of the straight line by representing its front view and top view as per the first angle projection using orthographic projection method. Here we will be defining the true length of the line and also the shape. Here are some of the various the positions of straight line with respect to principal plane. The horizontal plane and vertical plane are both principal plane. See here the first condition, a line is parallel to both horizontal plane and vertical plane. A straight line AB which is parallel to vertical plane and also horizontal plane. So here we have to draw the top view and front view as per the first angle projection. See, when the observer views from the front view direction, the line AB, the image of the line AB will be projected on the vertical plane. So it will be viewed as a straight line. Same when the observer view from the top view direction, the line AB will be projected on the horizontal plane. So the top view will be seen on the horizontal plane. So finally, we can able to draw in 2D by following orthographic mode. So the front view and top view are considered as a straight line directly with the measurement of the line. That is true length is nothing but the measurement, the actual original measurement of the line. The next condition, the line is lying on the horizontal plane and parallel to the vertical plane. A straight line AB found to be resting on the horizontal plane and it is kept parallel to the vertical plane. So the same method we have to follow. View from the front view direction. Draw the front view. Here in this case, when you extend the two end point A and B, the front view image of the straight line AB will be projected on the reference line, XY line itself. So A dash B dash line, that is what the front view image. The top view will be considered on the horizontal plane. See AB at a few distance away from the XY line, the line AB, the top view, resting on the horizontal plane. So here we have to give some offset distance, draw a line AB parallel to A dash, B dash. So this is the top view and this one is the front view. Next condition, a line is resting on vertical plane and it is parallel to the horizontal plane. Okay, so the line AB contained on the vertical plane and it is facing parallel to the horizontal plane. So in this case, we have to draw the front view and top view of the line AB. So use the same projection method. The observer standing in front of the vertical plane and viewing the object from the front view direction, the line AB at a few meters away from the XY line, it is found to be resting on the vertical plane. So draw the front view directly, A dash and B dash. Now see the same object line AB from the top view direction. So here the top view will be found to be coincide on the XY line, reference line, A and B. So correspondingly draw the front view and top view in two-dimensional, that is orthographic mode. These are the special cases. A line perpendicular to VP and parallel to HP. A line perpendicular to VP and parallel to HP. Draw the corresponding views, the front view and top view. Here the top view gives the true shape of the line AB, whereas the front view, the line looks like a small dot, a point, because oh, the line is facing perpendicular to VP. So when you view from the front view direction, only the point B is considered to be the visible point, whereas A is the invisible point. The straight line looks like a small point. That is the shape of the front view. And this point will be found to be projected on the vertical plane. The front view will be projected on the vertical plane. And we have to name as A dash and B dash. In this case, a line perpendicular to the horizontal plane and parallel to the vertical plane. So here, vice versa, the top view will be seen as a point and front view will be considered as a true line, as a straight line. The next case, a line is inclined to HP and VP and parallel to the picture plane. Okay, so this is the picture plane which supports both horizontal and vertical plane. The line is inclined to HP and also inclined to VP, and it is considered to be parallel to the picture plane. So this is the corresponding the top and front view of the straight line. So the next case, the line inclined to vertical plane and parallel to the HP plane. So the line AB inclined to the vertical plane and facing parallel to the horizontal plane. So you have to draw the front and top view according to the orientation of the straight line with reference to the plane. Here it is inclined to horizontal plane and parallel to the vertical plane, and both inclined to horizontal and vertical plane. So these are the special conditions in the projection of straight line. The problems will be solved based on these special cases. So we will start one simple example. Take a line AB 200 mm long, as its end A 75 mm above the horizontal plane and 50 mm in front of the vertical plane. The end point B is in first quadrant. So the line is parallel to the vertical plane and makes an inclination of 30 degree to the horizontal plane. Draw the projection of the straight line AB. So we will go step by step. So in the first stage, they are given the end point of the line AB. The end point A, how much mm above the horizontal plane? The 75 mm above the horizontal plane and 50 mm in front of the vertical plane. So draw A dash and A dash and A. Okay, 75 mm and 50 mm above and below. And from here, measure the line whose true length is 200 mm long. So draw two parallel lines, A dash, B dash, and AB, 200 mm long. Now, what is given? The line AB is inclined to horizontal plane. The angle of inclination is 30 degree. So now you tilt the line at an angle of inclination 30 degree. So the front view is slightly tilted at an angle 30 degree. So as a result, the image of the top view will get foreshortened due to the angle of inclination. It is not the same what we refer to stage 1. So you compare the length of the line AB and the next stage number 2, it is entirely different. The thing is, here the line is viewed at an angle 30 degree. So when you project these two in, we will not able to get the same image of the top view. It will be in reduced format. So next example, the same type. Here the line is inclined to VP and parallel to HV. Here the top view is inclined at an angle 40 degree. So you have to draw the front view. So with this information, I summarize that the projection of straight line, the major goal is to represent the 3D line in 2D view by documenting the front view, top view, and sometimes the side view by projecting the end points of the line onto the corresponding reference plane. The resulting projection are also considered to be a straight line and showing the true length and angles relative to the particular reference plane. So this can be used to determine the true length and orientation of the original 3D line in pictorial projection. So with this information, I thank each and every one of you. We will meet in the next lecture, advanced lecture in mechanical engineering. So thank you all.